Up, Using the IP Protocol for Applications in Deep Space by Marc Blanchet.
Hello, good morning. I'm Marc Blanchet from VIAGENIE, from Quebec, so if you hear my Frenchy accent, that's why. This presentation is actually part of a large deck that has been presented to various different kind of audience. IP network engineers, application developers, Spacecom people, standards people, managers, and we essentially extracted the things that probably makes more sense for you today. And there's actually more slides than I will be talking, kind of more for offline viewing and reading. Talking about myself, I've been 30 years so in network engineering and protocols and standard development, 18 years in Spacecom and CCSDS, implemented the bundled protocol, and I've been the co-chair of the delay-tolerant network working group in the ITF. Most of what I've been discussing is in this document that is referred here in the slide, and it's a URL if you click on it. So I'm talking about Internet in space, or IP technology in space, or Internet protocol suite in space. But the key point, and often first thing they say, well, browsers won't work in space. You are right. Okay, so this is not about end users, using internet in space. It's just, nothing in this work precludes end users, but that's not the use case. And we don't need, for example, another consequences, we don't need to modify Earth Internet and users' software and devices. We only care about space applications that runs on, space organizations, server spacecrafts and stuff like that. It's not about Earth satellites or LEO. It's really about deep space. This one is like 5 slides for people that don't know deep space. It's to 1 slide for you guys. So deep space have long delays, interruptions, communications, sometimes very long, less usual links like one-way and variable bandwidth. So the question is, can we use our Internet protocol suite for deep space? A while ago, Vint Cerf, Scott Burley, Keith Scott, Lee Torgerson, and others from JPL actually concluded no. And the very short summary is that TCP, the transport protocols and applications, are way too chatty for delays and disruption in space. So not working, therefore, that triggers the invention of a new networking stack from scratch. It's called the bundled protocol. It's based on a store and forward design, which is its own new transport, routing, naming, security, neighbor discovery, application API, network management, name it. It's like we're starting from a blank page. And it's been coined as the DTN, delay and disruption tolerant networking. So typically DTN means bundled protocol, but in fact, here we're talking about DTN, but using IP. Internet and internet engineering has evolved since then. IoT, disruption of communications is typically in the IoT world, and we have new transport protocols such as QUIC. And the reassessment of the use of the Internet Protocol Suite for deep space was by a set of engineers, and I'm kind of showing what our assessment is, and the short answer is yes. We'll see if I convince you. So this is the deep space IP stack. So if you're kind of a network engineer, you kind of get that pretty fast. So layer 2, CCSDS, space links, 802.11, Wi-Fi, and 3GPP. Those 2 are being planned for Lunar and Mars on surface and Vicente and cislunar. We run IP over them, UDP over them. We'll give you a second why. And we have UDP that uses NTP and SMP, for example. We have CoAP, which is I'll go back in a minute, but CoAP is a kind of an optimized protocol for IoT, and then we have QUIC that provides security, and then over QUIC you can have apps, tunneling, media, and then you can have HTTP that also does apps and media. So I'll go from down up during that presentation, and with a bit of focus on applications itself. So IP and transport in deep space. IP itself doesn't have a notion about time, only up count. It's an unreliable delivery of datagrams. It has hierarchical addressing based on topology that enables aggregation routing, which is kind of a difficult for now for bundled protocol is to write the routing. But when the destination is not in the forwarding table, IP drops the packet and sends an ICMP error back to the source. That's how it works today. In deep space, those routers or relays need to instead buffer or store the IP packets until the next hop becomes reachable again. So this is kind of a queuing discipline or buffer management that needs to be added to an IP forwarding node. We did a prototype to verify that, about 200 lines of C code, no change to kernel. And storing packets or bundles is the same problem, depending on which layer you have. If you are, for example, today, MRO does store and forward while it's orbiting and then sending back either data from the rover to the DSN or the other way around, or bundle or IP. So store and forwards is the same problem for everybody. Transport, TCP doesn't work, way too chatty, doesn't work in deep space. That's one of the key reasons why the whole IP stack was put aside 20 years ago. TLS really won't work in deep space, nor any other protocol using TCP over it. UDP is unreliable, no notion of time. So UDP works just fine in deep space. So granted, you already have, those kinds of NTP, SNMP, media, RTP that works fine over UDP, therefore works fine over in deep space. The new reliable transport QUIC is using UDP, and that's a key thing that changed over since 2000. QUIC was invented about 10 years ago by Google, is now a standard in the ITF. Your current laptop is using QUIC probably 40% of the time, because 40% of the internet traffic currently uses QUIC. QUIC is not for quick, but it's actually quicker. And it's more modern transport protocol. So it provides reliable transport services. So whatever happens below IP, loss of packets, reordering duplicates, all those things are handled by QUIC. It's an end-to-end connection. And you can think of a connection, QUIC connection, as a big pipe, in the sense that you create a connection with the other peer, and then all the other requests and exchanges are within that connection. You don't have to, like TCP, reestablish a new connection every time. So you establish one connection, and then you do all the traffic, either one way or bidirectional, or initiated by one peer or the other peer. All this is through the virtual pipe, if you want. So it's actually even if QUIC was not designed at all for space, it's actually well suited for spacecraft, since spacecraft have multiple payloads and long-lived applications with Earth. So you establish a connection, you can even establish while the spacecraft is on Earth, then keep that connection, quote, quote, forever. It has a TLS security mandatory, so right away, and it's done on a single handshake. So you send the client send a packet to the destination for connection establishment. It includes the security association, and when the reply comes back, the two peers have a security association using TLS. TLS being the most, protocol, secure protocol being verified everywhere. It provides reliability, as I said, reordering, loss duplication. If the peer is already known, so if you have established a connection a while ago and you, for whatever reason, you lost it, if you can reestablish the connection, and at the same time as you establish, you could actually send data with it. Why? Because they already have a security association between the two, therefore they can verify themselves. It's called zero RTT in QUIC. QUIC provides reliable transport services. It's user space, no need to change the kernel. Can be easy. It's easy to deploy today. Can be updated. Very configurable. It carries HTTP very quick, so you can reuse any HTTP framework. But you need to be an adult. Why? Because HTTP frameworks typically sometimes think that you are always connected. Therefore, they kind of do really chatty stuff, but in fact, a framework which is really async and done for being careful about traffic is actually possible today. Yeah, and you have many application implementation in C, C++, Rust, Go, Python, Swift, Haskell, Java, and integrated into HTTP software, for example. QUIC is not only HTTP, but is most used as HTTP. So QUIC works for the space? Actually, no. Why? Because it assumes short delays in interactive communications and does congestion control. But if you set the various QUIC parameters to appropriate values, typically large, and then just to simplify the congestion control, because in fact, congestion control it's not happening in space. You actually buffer the packets or the data, because there is no link in the next stop is not available. QUIC may use proxies at Space Edge, for example. That's another possibility. So if you set the appropriate setting of the QUIC stack, you are able to send an HTTP request to Voyager. Obviously, we did this in a test bed and simulation, but what we did is essentially create a 18 hours delay each way, so 36 hours RTT, and then we sent an HTTP request, and then got the response after in the test bed. So you have the Wireshark trace here, or TCP dump shown in Wireshark. The first two packets are the connection establishment. The last two are the connection finishing, close, and 4 and 5 are the get and HTTP and the response. You could look into details later. We tried the HTTP download, 4 meg file download, 10 minutes delay. By the way, we also did this month, calendar or world clock simulation of 5 days, one trip. So 10 days, 5 days one way, 10 days round trip time. It takes a whole month to get the simulation working, and it worked. This slide deck has been done before we finalize the simulation. So here's again 4 meg download, 600 seconds, because we don't want to wait a month for the simulation.
Someone online has hot mic. Can you unmute yourself? I don't have it here. Thank you.
So HTTP itself doesn't have a notion of time. It's only some HTTP headers, such as cache control, expires that, if you use it, you don't need to. You need to properly set the value. Servers and clients are typically have timeouts, so you need to set the value properly. So you may, if you want, be able to design a space application using HTTP, REST API, and stuff with the right design. Asynchronous, local references to local assets, and timers set properly. You could even use various web optimizations at WSM or HBAC. Skip this one. Because you have IP, you have a rich tool set, so you can do media, one-way camera from space to Earth over UDP using RTP, RTSP over QUIC or over HTTP over QUIC as we do today, like when you watch YouTube or Netflix. We may want to do two-way audio-video conferencing. I don't know about Mars because you'll kind of wait for long, but obviously all this, what I'm saying, is for the hard problem of very long delays. If you think about the moon exploration, where moon is just a few seconds away, all what just I'm presenting is, you know, right on, no big issues. You can even do ET phone home using SIP because SIP is over UDP, so that's something we wanted to test. I said COAP, CoAP application protocol available for IoT. Since IoT have low bandwidth, low memory, low CPU, constraints environment, you know, intermittent links, that looks like, you know, really space. So now you need a network and you have application. Do you have a network services to manage that network? And so this is the last few slides is just maybe less network, maybe less application level, but things that showed that the part of the IP deployment is also done. So for example, for network management, we used to do a lot of SNMP, still the primary network management protocol and environment. It uses UDP, therefore it should work. There's no timeout in protocol. So we did a net SNMP on client server, 2 hours each way, 4 hours RTT, just worked just fine. And time distribution, this is a hard problem. I'm not talking here about PNT, but to distribute time to, you know, nodes in general. Time NTP uses a UDP, so it's possible candidate. It has very complex time machinery. We consulted the NTP experts, and they said, well, should work. Maybe not as precise as we have on the internet, but should work. Well, let's put it to test. 2 hours each way, 4 hours RTT. We set artificially the client system date to be 10 hours, so completely outside the RTT. So it's pretty bad clock drift. We did the NTP date, so to update the client clock. Worked. First time, accuracy of 30 seconds. We did it another time. Worked with accuracy now down to 2 seconds. So it seems to be converging depending on the clock drift. So as a summary, this is the IP stack where you could develop applications over UDP directly, use some of the protocols that are using UDP. You can use CoAP over UDP, or you can use QUIC either directly over UDP or send media or use HTTP. So that's what we're able to provide using an IP stack today, which is one of the issue with the bundled protocol, which is there's still a lot of work to do. I know I've been the chair of the DTN working group. So summary, by temporarily storing IP packets and forwarding nodes until links are back up, setting QUIC parameters, and QUIC will provide you a full connection for your application. Or if you don't need those kinds of transport semantics, a UDP-based protocol or application is just fine too. And you properly design application to be asynchronous and have our large timers, the IP protocol suite can be used end-to-end in space. That provides you significantly decreased costs. You're reusing everything we have, decreased risk, increased security. It's a well-known, very well verified security protocols, and increased access to knowledge and expertise. We have results from simulation in the test bed that have confirmed it's working, but obviously more work to be done. About the test bed, I will also say that if you would like to play with our test bed, we're open to offering access to it. So please contact me. This is it for my presentation. Any question?
Thank you.
or you don't believe me.
Yeah, I got a couple of questions online. I can jump in. Is there a QIC dissector in the Wireshark main line?
Yes, Quick is on the Wireshark for if, so that question seems to be very into, want to know. Quick is fully encrypted from first packet. So if you look Wireshark by default, you won't see any details about, you see almost nothing in terms of the Quick frames and stuff. What you do is you actually ask the client, please dump the key that you would be negotiating on a file, and then you tell TCP dump or Wireshark to actually use that file for decrypting, and then you get the whole details of Quick. So.
Another question, does it support IPv6 as well?
Yeah, that, we actually did some of our simulations using IPv6, so it's, what I just described is independent on V4 or V6.
Thank you very much for your presentation. Obviously, forwarding storage of the IP packets to be forwarded does increase the memory requirements on your router. So how do you address that? And are there limits? Are there drop limits? That sort of thing. Good question.
So as soon as you get, as I said before, as soon as you get a relay or something in space that has to keep the bits, the data, because the next up is unavailable, you have the same problem. So it's the same problem for MRO, for example, right now, right? The guys from Maros at GPL actually have to manage those things and the buffers and things. So there's no difference with, either, CCSDS level links, storage of frames, than bundle protocol and IP protocol. This is the same problem. It's a buffer space thing. One thing that you may know, is that we've been doing a lot of things with queuing, QoS, queuing disciplines and stuff within IP. So the tool set is very rich to handle those kinds of things, such as, which packet would you drop if your memory is full, right, or your storage is full. Then you have all kinds of tools right now, today, with, standard routers to do that. You could, forwarding, when the link is up, which packets do you forward the first, right? All those things are possible today, which aren't for BP at the moment.
Isaiah Garrett. So you mentioned deep space here, but I was curious about cislunar as well. Which missions and orbits would require using this IP stack?
Good question. Right now, it's like BP, right? But right now, BP has only a few missions that is in test mode. This is for networking, right? So as soon as you have, alternate paths of things. So the first, and what you have to understand is IP will be already on Moon, right? For example, Nokia with Intuitive Machines is sending a 3GPP antenna, and 3GPP works just over IP and provides IP services, data services. So you would have an IP network on Moon and around, right? Then the only thing remaining is the deep space link. So if you carry IP, then it's a seamless IP from your space mission, servers and applications over deep space and then to Moon and back. Way simpler for, getting data and, sending data and controlling robots, and all those things become a seamless environment.
Thank you.
Oh, any questions?
Yes, one more question. Thank you for presentation, and just going back to your example with the Voyager. I'm just curious how have you implemented this protocol on Voyager, which is far away, and how this communication was possible?
So. Okay, I thought I was clear, but this is on simulation, right?
Okay, it was simulation.
Yeah. I'm sorry. I want to, punch something so you listen to me, but, I was not saying. No, it's not all. And if you need any additional information, there's an ITF space mailing list, a website, the draft itself and contact me if you have any other questions. I'm going to be here this morning up to lunch.
Thank you, Marc.